All right, so today is I guess it's the second C lecture. It's the first really substantial C lecture, though. Title of the slide, title of the talk, objects, functions, and types. Now, you might wonder why there are these things called objects, given that C is not an object-oriented programming language. Okay, well, the reason is as follows. So the C standard, so there's actually a standard document that describes the language. Very dry, right? So it's very formal, specifies exactly how everything works. The standard refers to objects, right? These aren't objects in the object-oriented programming sense. Okay, so that's what you have to be clear of, right? Not object. They're so not like Java objects. In C, an object is just a chunk of memory or data storage, right? So region of data storage, i.e. chunk of memory, the contents of which can represent values, right? So in other words, an object is literally a chunk of memory that represents some kind of value. Okay, so that's what the standard says. Or when you see the term object batted around, used in the C context of C, they just mean piece of memory. You interpret that memory as some value. So variables obviously are a type of object, right? So you make a variable, in this case, x, right? And so x, in this case, is an int. So creating variables in Java, in C is it's the exact same as how it works in Java, right? So Java was intentionally designed to closely resemble the C language. Now, because you all know how to program, and you know how to program a little bit in Java, right? Declaring variables, writing loops, writing if statements, everything's exactly the same. So when you write int x semicolon, that means you've got a variable called x, and the type of that variable is an int. Right? So in other words, you've got a chunk of memory, its label is x, represents an int. Sorry, that's the cat, if you hear meowing. Functions in C are more or less Java methods. Right? They even look the same. Except there's no access modifiers in C. There are no static, you can't label a function static in C either. I don't think you can anyway. So there's no public, private, protected, things like that, right? So there's no access modifiers in C. Functions are not objects in C. All right, so, but they do have a type, which is kind of interesting. So the type of a function is made up of the return type and some other stuff, right? And some other stuff. But we'll talk more about this when we talk about pointers to functions, right? So we'll come back to this point later on. Now, what's a pointer? All right, so remember in Python and Java, everything is all variable, in Python, all variables are references to objects. In Java, any reference variable is a reference to an object, right? And in 124, you were probably told that a reference can be thought of as being the memory address of an object. So in C, a pointer is exactly that. So C, a pointer stores the memory address of some object. So you can have a variable that's a pointer type. Now, unlike Java, right? So in Java, you have a reference, right? You can't do anything with the reference, right? You can call methods that belong to, you can call methods on objects with a reference. You can check if two references refer to the same object in memory, but that's all that you can do. Right. Pointers in C, you can do a lot more with them. In other words, so basically in C, the programmer has or is able to get direct access to something in memory, right? Which is very different than how Java works, right? So in Java, you can get to an object using a reference, but all you can do is with that reference is call methods on the object. You can do a lot more with a pointer. So the type of a pointer is derived from the type of the object pointed to, right? In other words, if you have an int object, then you can get a pointer to that int object, right? The type of the pointer, right, is declared using the asterisk. Right. So if the type of the object pointed to is t, so in other words, if I have an int, right, then the type of a pointer to that object is pointer to t, right? So pointer to int. Now, how do you declare a pointer? Right. So back here, right, we had x, right, int x. So if I want a pointer to an int, right, then you write int star, right, and then followed by the variable name. So here, p is a pointer to an int, right? So that's one way to declare a pointer variable. That's the style that you will see in C++, right, which we aren't using in this course. Right. If you look at the Linux coding standard document, then they say pointer should be declared this way, right? So int space star and then p. So the name of the pointer variable immediately after the asterisk. Says that p is a pointer to an int. Right. And then finally, it turns out the space isn't important. So you can write int space star space p, and that's p is also a pointer to an int. Okay, so pointer to it. So in other words, in all three examples here, right, p is the address or the memory address of some int object, some int value sitting in memory somewhere. I think in this course, I'm always going to use the second form. When you're reading someone else's C code, it's not unusual to see that. It's also not unusual to see this style too. Right? There's no agreement on which of the above should be preferred. Right? So it depends on who you talk to. If you end up in a job that uses C as the programming language, then you simply follow the coding standard dictated by the company that you're working for. Right? And it might be any one of these three. The coding standard could also say it could be any of these three. So no common standard is, there's no agreement on the standard to use. All right, so we'll come back to pointers in a little bit. C uses pass-by value to transfer arguments to functions. So that's just like Java. I think it's also like Python as well. So in Java, right, you can't write a method that swaps the value of two primitive type variables for the caller. Right. So in other words, if I'm using a method and I call the method with two values x and y, right, two int values x and y, then after calling the method, my int values x and y are the same as what they were when I called the method. The method cannot change the values of x and y. Right. So for example, here's a main method in Java, right? This is Java. So we got a class swap. We've got two static methods. One of them is the main method. Right? X and Y here, they're 1 and 2. I call swap. Right? Swap tries to swap the value of x and y. Right? So you make a temporary variable, set it to x, change the value of x, then change the value of y. Right? Standard swap method. When you call swap here, right? What happens is it's not the variable x that gets passed to the swap method. It's the value of x, right? So it's the number 1 that gets passed up to here, right? It's not the value, it's not the variable y that gets passed to swap, it's the value of y, right? That's why it's called pass by value, right? So that line there is effectively swap 1, 2. It's not really swap xy, because it's the 1 that gets copied up to here, and it's the 2 that gets copied up to here. When you swap the parameters x and y, while the value of the parameters x and y change, but these x and y, they don't change. Right? So when you print out x and y, you get 1 and 2. And that's the way it works in Java. That's the way it works in Python. That's the way it works in C. So if you were to write the equivalent method in function in C, you would see the exact same results, right? So we can do that, right? The method even looks like it almost looks exactly the same as Java, right? Get rid of the public and static, right? And change system out print line to printf. Everything looks exactly the same. Right? So the only difference is, right? Here, printf, right? That's the only difference. So printf is formatted print. The way formatted print works is it's got a formatting string here. Right? So there's some string, it can be a variable, right? But here it's a literal. Right? So there's some string here that tells printf how it should interpret x and how it should interpret y. That %d means interpret the first argument after the formatting string to be as an int or as an integer value, right? And then the second %d means interpret the second argument after the formatting string as an integer value, right? So this will print x equals x space equals whatever the integer value of x is, comma, space y, space equals space, whatever the integer value of y is. /n or \n means new line. So if you run this program, which I think I have up somewhere, where is here? Right. There's swap. To run this, remember you have to compile this because it's a C program, so you got to do it by hand. I guess if you have an IDE, you don't have to do it by hand, but I'm going to show you how to do it by hand anyway. Right. So remember to compile, it's GCC -o name of the program that you want to produce. Right. So I want the executable to be called swap, and then name of the file to compile. So that's swap.c. Right. Press enter. Everything works. Run the swap program. So /swap. And it prints out 1 and 2. Right? So the exact same thing that happens in Java also happens in C, and it's because of the way they transfer values back and forth between the way you pass an argument to a function is via pass by value. The way a function returns a value back to the caller is also pass by value. Right? So swapping what's going on here? Swapping two values for the caller is not possible, because the function does not receive the variables storing the values, right? It receives the values, does not receive the variables. Now, in C, it is possible to write a function that does, in fact, change the values of x and y. But what you have to do is you have to pass pointers to x and y. Right? For example, if I rewrite the swap program, to use pointers, it ends up looking like this. Okay, so let's look at the swap function first before we look at the main function. Okay, so instead of taking in an int x, we're taking a pointer to int x. Instead of passing in an int y, we pass in a pointer to int y. Now, remember what pointers are, right? So x here is the address of some int value. Right, of some int variable, sorry. X is the address of some int object, right? Y is the address of some int object, this function. Now, can I get the value of the object that X points to? The answer is yes. So if you write star pointer variable, right, then that's what's called a dereference. Right? In other words, it gives you the value that x points to. The int value that x points to is *x. Now, you can use *x on the left-hand side of an assignment statement. Words, right? I can say, right, value of x, right, or the, sorry, let's look at the right-hand side first, right? The value of the object that y points to, I want to store that in the x object. So you can use the dereference operator on both sides of the assignment operator. For y, that's the object that y refers to. Right? So the value that I'm going to store in that object is now temp. Actually performs the swap, right? As long as I can pass in the address of x and the address of y. Right? Now here I've got variables x and y. Right? To get the address of x, you use the ampersand in front of x, right? So and x means the address of x, right? So that's a pointer to an int, right? Y, that's an int, right? So y is an actual int value, and y, that means the address of y. I can pass the address of x up to here. I can pass the address of y up to here, right? Now that this function has the addresses of these two objects, can actually change the value of those two objects. So if I print out the value of those two objects, you'll get 2 and 1 in this case, right? So they really will swap in this case. And I'm guessing this is swap 2. There, right? So there's the pointer version of the program. And compile the program. Oops, sorry, swap 2. And now when you run the program, right, the values really do change, right? You get 2 and 1. Right. So C gives the programmer the ability to actually perform a swap. In other words, you can in fact change the value of a variable by calling a function. You can cause the value of a variable to change. All right, so let's take this. Let's go through this one more time because it's a little confusing the first time you see it. Right. So our swap function, it's no longer taking in 2 int values. Instead, it's taking in 2 pointers to int values, right? Taking in the memory address of 2 int objects. If you have a pointer variable like we do here, right? So x is and star x is the object that x points to. Right now, like pretty much every other programming language, C uses operators, or C redefines operators based on their context, right? So star means something different than multiplication in this context, right? It also means something different than int star. Here, the star is used to indicate that x is a pointer. Right? X times y, the star is used to represent multiplication, right? Star followed by a variable name, that's a pointer, means dereference the pointer, right? So star in this case is the dereference operator. So when you dereference a pointer, that gives you the object that is pointed to. Right? So in this case, star x is the int object that x is pointing to. So int temp equals star x means take the value of the object that x points to and store it in temp. Right? So that's what that means there. On the next line, right, star x equals star y means the object pointed to by x is assigned the value of the object pointed to by y. So dereference x, dereference y, right? That gives you the int object that x points to, and it gives you the int object that y points to. And finally, star y equals temp, right? Dereference y, that means give me the y object, give me the int object that y points to, and assign the value of temp to that object. So this really does accomplish the swap. Now, the AND operator is also overloaded in C, right? So in other words, it has a different meaning. Normally, AND is, or double AND is the AND, is the logical AND operator. The single AND on its own is the bitwise AND operator. And in front of a and in front of a variable name means give me the address of that variable. Right. So and x means give me the address of the variable x. Right. And y gives me means give me the address of the variable y. Right. So what's the point of getting the address of x? Well, that's a pointer. What's the point of getting the address of y? Well, that's a pointer. Right. And I need a pointer to call the swap method. All right, so that's the quick introduction to pointer. We're going to be seeing pointers with some regularity in the course, so we'll come back to this, right? So if you're still a little bit confused on on what a pointer is, just go back, review the slides and the lecture video, and we will come back to this topic. Scope. So you already know something about scope from Java and Python, I guess, right? So in C, the contiguous region of the program where a name can be accessed is called the scope of the identifier. Right now in C, there's so in Java, for example, you know that if you declare a local variable in a method, right, then the scope of that variable is the entire method. C has 4 different types of scope. So C, there's what's called file scope, right? So you can kind of guess that the name is usable in the entire file, right? Block scope, that's the type of scope that you're familiar with from Java, right? So anything declared, any variable declared in a set of braces is usable anywhere after that point in those braces, right? Or in that block, right? So that's block scope. That's the same as what C. It's similar to how it works in C. There's something called function prototype scope, and there's something called function scope. So those are easier to describe by showing you examples. Okay, file scope. Now in Java, everything lives in a class, right? So if you make a variable that's inside of a class, then that becomes a field, right? And it's usable only inside the class. Now in C, there are no classes. So it's possible to declare a variable that's not inside of a function, right? So you just create you just have a, do I have an example? I do. Okay, so you just declare a variable somewhere in your C code that's not inside of a function, right? Then that's what's called file scope. So that variable is usable everywhere in the file after the point at which it was declared. So here we go. Right. So here I've got a variable called j, right? Its type is int. Right? It's not initialized, right? So it hasn't been assigned a value yet. So there's j, right? Now look, I've got a j here. I've got a j here, right? And I've got anywhere else? No, I don't have one anywhere else. Okay. So when I say j, which j is meant, right? So I've got j up here. Here I'm using j, right, inside the main function. So that j there refers to that variable up there. Right. This j here also refers to that j up there, right? So that's what the arrows are telling you. They're telling you which j is being referred to, right? So they point, they're showing you the actual variable. Now, what happens if you run this program the way it's written, right? So what happens if I print out the value of j, right? Does it have a value? Well, we'll find out shortly. So we'll come back to this. So that's file scope, right? So j is declared outside of a function, so it has file scope. Braces. So like Java, braces denote blocks of code. If you declare a variable inside of a block, then it's usable. Then that variable has what's called block scope. The identifier is accessible everywhere in the block after the point in which it was declared. And block scope will override or hide file scope. So here's an example of I. So it's declared in the parameter list, right, of the function f. Anywhere inside the function, not anywhere, right? Inside the function, I can use the name I. Right? For example, when I use I here, right, I mean the parameter I. I use I here, I also mean the parameter I. Okay. Now inside the for loop, right, I'm declaring I again, right? So this I that's used here is not the parameter I, right? That I here is the I that was declared for the for loop, right? So it's going to start at 0 and go to 1 and 2, regardless of what that value is there. Right? After the for loop, right, this I goes out of scope, right? So in other words, after the for loop, that I is not usable, but I've got this I up here, so I can use its value there. The arrows are indicating which I is meant. So scope scopes can be nested, right? Identifiers with the same name can be declared in different scopes. The identifiers at the inner scope, they take precedence over the ones declared at an outer scope. So the standard says that the outer scope identifier is hidden by the inner scope. Right, so that j, right, when I declare j inside the function f, it hides that j that's here. So now anywhere inside the function where I use j, right, it might mean that j there. So here, that j means that j, and that j means that j. Right? But notice I'm going to redeclare j inside of another scope, inside the an inner scope. Right? So a scope that's interior to the function scope. So I'm redeclaring. Oh wait, so what are we doing? I? Oh, we're using I in this case. Okay, so here, this I hides that I. Right? This j hides that j. So here, when I use the names I and j, I mean that j and I mean that I. Okay, so let's see if I got this file kicking around somewhere. See what happens when we run it. And hopefully I called it something. I did. Okay, so it's called scope. All right, so there's our program. Drag it over here, and let's compile and run that program. Again, GCC -O, I'm going to call it the runnable program. I'm going to call it scope. Right. The file I want to compile is scope.c. All right, so what happens when we run the program? Okay. Oh, did I tell, is there a /t's in here? There must be /t's, okay. I'll explain what the \t means. All right, so the first thing that prints out is j equals 0, which is that line here. Right, now, j is uninitialized here. So whether or not it's always 0, we'll have to wait for later when I explain how variables are or are not initialized by a Java program. All right, for now it's 0. Okay. So there's our first printf on line 17. Then we call the function f with the value 100. So we come up here, I is 100, j is 1. Right, add 1 to I, so it's 101. So this prints out 101 and 1. Right, which is showing you that it's this j and that I that's being printed at this point. Right, then we come to the loop. Right, the loop is going to hide I and j. Right, so in other words, it's going to loop 0, then 1. Right, each time through the loop, j will be 2. Right, so here you can see I is 0, j is 2, I is 1, j is 2. Right, but remember, it's this I and this j that are changing. Right, so after the loop, it's the I and j that were declared up here that get printed out. Right, so it's 101 and 1 again. Right, and then when we return from the function f, right, the j that's printed out here is that the value of that variable j that's up there. All right, function prototype scope. So function prototypes. All right, so in Java, in C, a function prototype is a declaration of a function. So it's not the definition, right? It's the declaration. So this is similar to an abstract method in a Java interface, or it's similar to a method in a Java interface, right? So remember, in a Java interface, all you get is the declaration of the method, right? You don't get an implementation. So a prototype is similar. You get the declaration of the function, you don't get its definition. And it turns out the C compiler can compile a C source code file if it has only the prototype. Right, so it doesn't actually need the definition to to compile a single source code file. Right. Eventually, the function has to be defined somewhere. Right. But to compile the individual source code file, it only needs the prototype. So the prototype includes the return value, the return type, the name of the function, and the parameter types. Right. It doesn't even need the parameter names. It just needs the types of the parameters. it does not, the prototype does not include the implementation. So I can declare a function called SumFunction. This is the prototype of the function SumFunction. So here I've got void, right? So that's the return value type, name of the function, parameters, right? My parameter list. So here, if you give the parameter a name, then A has what's called function prototype scope. In other words, this name A is usable, right? Anywhere after it's declared inside of the parameter list. Right? In this case, it's not, we don't use it again, right? Here, however, we've got another function prototype. I've got an int parameter called n, right? I'm going to use n again after I declare it. Right? So here I've got an array A. So this is an array of int of length n. So this is array A of size n, right? And this is legal in C, right? It's legal because the n has been declared here, right? Before it's been used. If I switch these two around, it doesn't work. The compiler will complain. But declare n, use n inside the parameter list is legal. This case has function prototype scope, right? Variable n is usable anywhere after it's declared inside of the parameter list. Usually it's not interesting, right? For our purposes, this almost never happens except when you're working with arrays. I tell you what, there's another one. There's one more scope, function scope. Okay, so we don't talk about it. Right. We don't actually talk about this in this course, although if you want to, you can look it up. In C, you can label line. Actually, you can do it in Java too. You can actually label lines of code. So you can give a line of code or a block of code a name in C and in Java. And then there's a mechanism where you can go to that line or block of code. So in that case, those labels have what are called function scope. So look this up if you're interested in learning about this. But I don't think I'm going to talk about this anymore in the course. Essentially, to get to a label, you use the goto statement, which is kind of frowned upon, which is one of the reasons why it's not taught in this course. Storage duration. So this is storage duration is related to the scope of a variable, right? So storage duration is the lifetime of an object, right? So in other words, when is an object valid? When is the use of an object valid, right? It's determined by its lifetime. Now, remember, in Java, you don't really care about the lifetime of something for the most part, right? So, for example, you know that in Java, if you use new to make an object inside of a method, right, and you don't return the object, then the object goes away on its own, right? You don't worry about the lifetime of the object, right? If you return a reference to that object, right, and that's fine, right? Everything works the way you expect it to. That's not necessarily the case in C. So in C, the programmer is able to control the lifetime of an object. Right? So you need to know about storage duration. There's four types of storage duration in C. The last one we don't talk about. Right? So there's something called automatic storage duration. There's static storage, allocated storage duration. Right? Allocated we'll talk about a little bit later. So it's these two that we're interested in right now. Automatic storage duration. So the default storage duration of objects declared within a block or as a function parameter is automatic storage. Right? So if you have a function and you make a local variable in that function, then by default it has automatic storage duration. Right? So what does this mean? It means storage or memory, right, is allocated when the block in which the object was declared is entered. Right? So when that block of code runs, right, that's when memory for that object gets allocated. After that block is done, the storage is deallocated. Right? So after that block is done running, the storage is deallocated. Now, it may not happen immediately, right? So it might not instantly happen, but whatever you declared inside that block, there's no guarantee that what was declared inside that block is still valid. Okay. So in that example again, right, same example from the previous slides, right? I is a parameter, so it has automatic storage duration. Right? When you call the function, I becomes alive. Right? When you exit the function, I is considered dead. Right? So it's considered dead. Right? So if you try to use I, if you somehow get try to use I after the function returns, right? There you have no guarantee that the value of I is correct or even meaningful. Right? Now you might ask yourself, how am I going to get the value of the parameter I, right? So the answer is you can return a pointer to I from the function, right? But if you do, you're returning a pointer to an object that is no longer valid, right? So if you do that, you're almost guaranteed to get an incorrect result. Here's another, right? So remember I and J, these are both local variables, so they have automatic storage duration. I is valid. I is born, I guess. Once the loop is when the loop initializes the value I. Right? J is born when the loop runs once, right? The first time the loop runs. I and J are no longer valid, right? When the loop ends. So that's automatic storage, right? Any local variable is automatic storage. Any parameter has automatic storage. Okay, so now there's something called static storage duration. So a variable declared at file scope has what's called static storage duration. It's also possible to create a variable in a block that has static storage duration, and the way you do that is with the keyword static, which is not the same thing as what static means in Java. Remember, static in Java means the thing belongs to the class. Static in C means the variable has static storage duration. So what does static storage duration mean? It means its lifetime is the entire lifetime of the program. So the lifetime of a static variable is the lifetime of the program. The value stored in the object is initialized only once, right? And it's guaranteed to be initialized before the main function runs, which is a bit unusual, but that's the way it works in C. So J, right, declared outside of a function, so it has static storage duration, right? The lifetime of J is the lifetime of the program. J is initialized before the main method ever runs. Sorry, J is born before main runs. Why are these arrows here? These arrows are wrong, I'm sorry. Now, if you want to, you can create a static local variable, which is a little unusual, but it does have some applications. All right. So here's an example where we've got a function called increment. Okay. Increment returns the value of an internal counter. Right? So it returns the value of this variable here. So counter declared to be static, right? So in other words, this value counter is born before the program ever starts to run, right? So it's it becomes alive before the main method runs, main function, sorry. Right, and it gets set to 0 in this case. Every time you call this method, this line does not run, right? Every time you call this method function. Sorry, teaching 124 in this course is hard because Java calls things methods and C calls things functions. Line only runs once, right? And it runs before the main function runs, right? Every time you come into this function, this line does not run again, right? So the first time you call increment, we increment the counter and then return the value of the counter, right? So the first time you call increment, its value will be 1, right? The second time you call it, its value will be 2, right? It remembers its value between calls, right? Because it's static. Right, so the second time you call it, its value would be 2, and then 3, and then 4, and then so on. So let's assume it's called, oh, what's it called? Static? It's probably called static. It's, okay, so go. Right, so there's our program. Compile the program. All right, name of the program to compile. There we go. And run. So we got a loop here. It calls increment 5 times. Right, so this should print out 1, 2, 3, 4, 5. Right, so you see that the value of counter is preserved between calls to the function. Okay, initialization of static variables. Normally, you initialize a static variable where it's declared, right? So for example, whoops, sorry. Right, so here I explicitly initialize the value of counter to 0. However, static variables are special, right, in C. Unlike unlike variables that have automatic storage, right? So static variables, if they are not initialized, then the compiler will initialize the value. So if it's a pointer, the value of the pointer is initialized to the null pointer. So the null pointer is like a null reference in Java, right? A null pointer points to nothing, right? If you try to use a null pointer for almost anything, it'll fail, right? You'll get some sort of error because it points to nothing, right? So you can't dereference a null pointer. Is that true? Can you? I don't think you can dereference a null pointer. You can't use it to get the value of the point. Yeah, so you can't dereference a null pointer, right? So it's not really usable. Okay, if the variable has arithmetic type, then it gets initialized to 0. Technically, it gets initialized to positive or unsigned 0, but it gets initialized to 0, right? So if it's an int or a double or a float, well, there's a bunch. I'll tell you about the types later, right? But if it's any sort of numeric type, then it gets set to 0. If it's an aggregate type, which we'll see later on in the course, then these two rules are applied recursively, right? And if it's something called a union, then these two rules are also applied recursively. I'm not sure if we're going to talk about unions in this course. They're unusual. But we definitely talk about these things here later. Right. So that's why when we ran our program here, this one, right? So even though we didn't give J a value, right, it's guaranteed to be 0 because it has static duration, right? So because it's static, because it has static allocation, it automatically the compiler initializes its value to 0. I guess that's a good place to stop. There's no point starting the next lecture. I think the next lecture I'll tell you about the actual types that are in the language. So anybody have any questions about the content in today's lecture? If it's about pointers, do remember that we will revisit pointers many times in the course. All right, so I don't see any questions. I guess we'll just end the lecture there. And when do we see you next? Tomorrow, right? Yeah, so tomorrow at 1:30, I'll see you in the next lecture.